Hello, fifth graders. Today we're going to be working with something called step graphs. You never worked with step graphs in everyday math in fifth grade. Some of you might have saw it a little bit, but it wasn't part of the curriculum. So step graphs is new to sixth grade, but it's not too challenging. Basically, a step graph shows a period of time that kind of stays the same with some gradual jumps to it. You'll see what I mean on this next slide here. Here's a step graph that shows, it looks like steps going right up, okay? And it shows something with an athletic training times or starting times. Well, let's see what's happening here. We have the time listed on the left here, 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 p.m. At the very bottom, we have the age of athletic participants. So what this simply means is the age range, so it kind of shows a little range with it. From 7, 8, and 9-year-olds will have a starting time at 8 a.m. 9, 10, and 11-year-olds will have a start time of 9 a.m. 11 to 13-year-olds will be at 10 a.m. 13 to 16-year-olds will be at 11 a.m. 15 to 17-year-olds will be at 12 p.m. Let's move on. Taking a look here, we also have aquarium sea show times. So at 10 a.m. you have the seal show. At 11 a.m. you have the crab crawl. At 12 p.m. you have the dolphin show. Then you have feed fish at 1. Shark show goes from 2. These are all 1-hour shows. It's pretty interesting. Here we have a little problem here. We're going to kind of see it. We're going to analyze it. We're going to work through it. It looks kind of tough with all these words, but let's go through it and we'll do this together. The cost of mailing a first-class letter in the United States depends on how much the letter weighs. The table at the right shows the first-class postal rates in 2004. 37 cents for a letter weighing 1 ounce or less. 60 cents for a letter weighing more than 1 ounce, but no more than 2 ounces, and so on. So here's the prices. Notice the placement of the dots on the graph. I'm not showing you the graph, but we'll keep going here. For example, on the step representing 60 cents, the dot at the right end above the 2 shows that it costs 60 cents to mail a letter, weighing exactly 2 ounces. There is no dot at the left end of the step. That is the intersection of 1 ounce and 60 cents, because the cost of mailing a 1 ounce letter is 37 cents, not 60 cents. So if we take a look here, 1 ounce is 37. 2 ounces is 60. 3 ounces is 83. So once you get to that 2 ounce mark, it actually goes up 23 cents per time. It has an increase of 23. You see how that works, kids? If you add 23 cents to each one, it goes to the next ounce. So the question down here says, using the rates shown on the table, how much would it cost to send a letter that weighs 4.5 ounces? Well, what's half of 23? Half of 22 is 11. Half of 23 is 11.5. So if we're at $1.06 and we're adding, we can round this up to 12 cents. That would give me $1.18 for my 4.5 ounce. Does that make sense? If that'd be $1.18 right here? It sure does. Let's move on. Kind of problem solving with this. Using the rates shown on the table, how much would it cost to mail a letter that weighs 6.5 ounces? Well, as you can see, everything's going up by 23 cents, plus 23, plus 23, plus 23. 6.5 would be right here, okay? 7 would be another 23. So remember that half mark would be about 12 cents, right? So let's add 12 cents too. 1.52 plus 12 cents. Be $1.64. That's how much. So how do you determine your answer? Well, we figured out that it's increasing by 23 cents per ounce. So we just took that 23, divided by 2. We got 11.5 cents, right? Because 11 plus 11 is 22, plus another half would get us up to that 23 mark. And then we just added that to that last one. Let's take a look at this graph here. Okay. Now we're going to graph this data onto this next page. So let's take a look. I think they already had some of it done for us. They do. So we have to graph the next one from 2 to 3. 83 cents. So where's the 83? It'd be right there. Go here all the way to the dot right there. I'll change colors on this too. Now we're going to $1.06 for the 4. $1.06 would put me right about there. Okay. Back. $1.29. $1.29 puts us right about there. And the last one, 152. Put me right about there. You can kind of notice that it's just increasing by 23 every time. And there are your steps to your graph. Looks just like that. Let's take a look at these problems right here. So we're not going to solve this. We're just going to round an estimate. You're going to have something in your math box say it's going to ask you to estimate what a reasonable answer would be. And when we're estimating, anything that's at 0.5 or above, we're going to round up. So this 4.5, we're going to round up to a 5 because this is a 5 or greater. 5 times, we're going to round this because it's an 8. It's bigger than a 5. So round this number up to an 8. 5 times 8 is 40. That'd be your estimated answer. Let's do another one of these. 2.3 would round this down to a 2 because the 3 is less than 5. This 5 is a 5 or greater, so that means this 9 would round up to a 10. This is 2 times 10, which equals 20. 6.5 would round to a 7 because the 5 would make the 6 bigger. 7.4 would make this round to a 7. 7 times 7 equals 49. Here is our last one. 5.9 rounds this up to a 6. 8.8 rounds this up to a 9. 6 times 9 is 54. That is how you round to the nearest number. Hopefully step graphs, you're going to have a couple step graphs in your assignment today. You're going to do some rounding, and that will be your math lesson today. Hopefully this helped as a little review and you learned something new. Good luck on today's assignment.